Have you ever wondered how beautiful geometrical surfaces like cylinders, cones, and spheres are formed? Well, the answer lies in the fascinating world of generatrix and directrix. This concept is not only the basis of geometry, but also plays a pivotal role in the functioning of conventional machine tools. Let's start by understanding what generatrix and directrix are. The generatrix, also known as the generating line, is a line that moves to generate a surface or a solid figure. Think of it as a pencil sketching a line on a sheet of paper. If you move this pencil line along a certain path, it creates a surface. This movement can be straight or curved, depending on the surface you want to produce. On the other hand, the directrix is the path along which the generatrix moves. It can be a line in the case of a cylinder, a point for a cone, or a circle for a sphere. The directrix guides the generatrix, and together they create the magical world of geometrical surfaces. Now that we have a basic understanding of these terms, it's time to connect them to conventional machine tools. Machine tools like lathes, milling machines, and drilling machines use the principle of generatrix and directrix to produce various shapes and surfaces. For example, in a lathe, the workpiece acts as the generatrix and the tool movement provides the directrix. The kinematic systems and structure of these tools are designed to provide a controlled path, directrix, for the cutting tool, generatrix. This, combined with electromechanical or hydraulic drives, allows precise control over the tool movement, enabling the production of complex geometrical shapes. Machine tool automation takes this concept a step further. By using computer numerical control or CNC, the directrix is programmed into the machine. This eliminates the need for manual control and allows for higher precision and repeatability in the produced shapes. Machine tools are classified based on their structure, control system, and the type of surface they produce. The specification of machine tools, on the other hand, includes details like size, power requirement, and the range of shapes they can produce. A variety of semi-automatic and automatic lathes use the concept of generatrix and directrix. These include turret lathes, capstan lathes, and CNC lathes. The construction and working principles of these lathes are based on the same concept, but differ in their level of automation and the complexity of shapes they can produce. In summary, the concept of generatrix and directrix is the basis of producing geometrical surfaces. It is integral to the functioning of conventional machine tools, their kinematic systems, and their drives. Automation in machine tools uses this principle to achieve high precision and repeatability. And finally, the variety of lathes available today are all based on this fascinating concept, differing only in their level of automation and the complexity of shapes they can produce. So the next time you see a beautifully formed geometrical surface, remember the magic of generatrix and directrix that made it possible.